Guys, so first of all, draw these points on a coordinated diagram. Okay, so you're going to get your just draw your two axes, x-axis and y-axis, and now 1 0 is here. 6 1 is 6 dots across, 1 up, which is here. So that's A followed by B. C is 9 4, so that's 1 2 3 4 5 6 7 8 9 across and 4 up. So that is C, and then finally D, 4 across and 3 up, and you have A, B, C, D. So that's what we have going on here, okay? So A, B, C, D. Everybody happy with that? Now, what type of quadrilateral is it? What's the name of it? Anybody? Parallelogram. Parallel, two L's, an EL, then ogram. Parallelogram. Okay. Find the length of each side. Are the pair of opposite sides equal in measure? So we have to find. We have to use all 4 points here. So I'll just bring them down with me. So all 4 points here, and I'm going to use the distance equation a couple of times. Okay, so I'll bring this down with me here, and I'm just going to start working on the distances between each one. So distance formula is square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So the distance is going to equal to the square root of something minus something squared plus something minus something squared. Okay, I'm going to have to do that how many times? I'm going to do it a full 4 times, guys. So a full 4 times, okay. So that's 1, 2, then 3, and then finally the 4th one. So we're going to do that 4 times. It's a lot of work there. Okay, so let's begin. Start with AB. Now, just looking at the diagram, we're expecting AB to be the same length as DC, and we're expecting BC to be the same length as AD. Okay, so these should all be the same length as each other. So let's find out. X1, Y1, X2, Y2. Let's start off with AB. So what numbers go where? 6 minus 1, 1 minus 0. What's that turn out to be, Cameron? Root 26. Okay. Let's go for DC while I'm here, just because it's easy. I don't have to change any of the points. X1, Y1, X2, Y2. Okay, so what's that then? 4 minus 9. Yeah, if you did it the opposite way, you'll still get the same answer. And then 3 minus 4. So what's the length of DC then when you put it in the calculator? Root 26. So DC is the same length as AB. Yep, that's perfect. Okay. Now we're on what ones then? We'll go for... We have to go for AD, isn't it? And BC. AD and BC. So AD being here, and BC being here. Now A and D, X1, Y1, X2, Y2. So 4 minus 1 squared, and then 3 minus 0 squared. And what you get for AD? 3 root 2. That's okay. When you put it in the calculator, yes? Yeah, they have to be equal to each other, yeah. No, you'd have to find out BC and prove that it's the same length. The key language is, it does actually tell you to find the length of each side. So by not doing that, you'd be disobeying the language of the question. Okay, so what's, I'm just going to drag this down here now, a bit further. So what is BC then? X1, Y1, X2, Y2, 9 minus 6 and 4 minus 1, and what happens there? Same thing, is it? 3 root 2. Are the opposite sides equal in measure? These two are equal, and then the other two are equal. So yes, opposite sides are equal in measure. We're good with that. Okay. So, yeah. Find the midpoint of the diagonal. How could you show that the diagonals bisect each other? Okay. So, find the midpoint of AC. So here's A to C. We can see on the diagram that it's going to be this point here, isn't it? Which is going to be 5 and 2. But look, we'll use the midpoint formula just to be sure. So what happens now? We get x1, y1 for A, and we're also using the point C, which is x2, y2. So 1 plus 9 over 2, and then y1 plus y2, 0 plus 4 all over 2, 10 over 2, which is 5, and 4 over 2, 5, 2. Okay? Now, how would you show that these diagonals bisect each other? Do you know what bisect means? Okay, what bisect means is if I drew a rectangle as an example, and I joined the sides of the rectangle, the diagonals of the rectangle to each other, what happened is this point here, it's the midpoint of this diagonal going this way and the diagonal going the other way. So in effect, it cuts it in half. Do you get that? Cuts it in half. So what I'm suggesting we do is, how do you prove that how can you show that the diagonals bisect each other? Well, if we join the other diagonal D to B, you can see that it goes straight through the midpoint. And if we show that this midpoint is also the midpoint of DB, it means that that point is central to the line AC and central to the line BD, which means that it cuts each line dead center. That makes sense? So what I do is I do the midpoint formula again, except this time it'd be for DB. So I'd have my x1, y1, x2, y2. Reusing the formula from before, we're going to get 6 plus 4 divided by 2. And then 1 plus 3 divided by 2, and that gives me 5, 2. Now, this one here, guys, a map of a shopping centre is shown here. Oh yeah. Why is it easier to calculate AB than PQ? Well, if we look at AP, it's just 3 blocks to the right, so it's a length of 3. However, PQ is a diagonal, so because PQ is diagonal, we'd have to use the distance formula, which is considered more difficult than counting squares right or left or up and down. Does that make sense? So now, if we were to go up, guys, we could do a couple of these straight away. I could say A to F is 3. I could say G to B 4, B to R 3, Q to R 2. So realistically, there's only 2 lengths I need to measure. There's only 2 times I need to use the diagonal formula or the distance formula, isn't there? So remember what I said earlier. We could just actually measure this out. We could do this one. So remember I said call A 0, 0, yeah? That makes this point here. Point F is 0, 3. And then 2 across and 3 up again. 2, 6. I can use the points 0, 3 and 2, 6. And what I can do there is I can use them to find the length of FG. So the length of FG, and if somebody's active on the calculator with this, it'll make it a lot easier. X1, Y1, X2, Y2. So what we get is 2 minus 0 squared plus 6 minus 3 to be squared. Any of these? I'm going for the square root of 13. 2 squared is 4, 3 squared is 9, 4 plus 9, 13. Uh, 3.6 what? Okay, so 3.6 for that one. Next thing we're going to do, guys, we're going to figure out what is the point P and the point Q. So let's find out what PQ is. Okay, so P is 3 to the right. What's 3 to the right of 0, 0? 3, 0 is P. What's the point Q? 1 across is 4 and 3 up is 4, 3. Allocate them values. x1, y1, x2, y2. Yes. Guys, what we're going to do next is find out PQ. Okay, guys. So we're going to have next is we have to find out what PQ is. So P to Q is the square root of x2 minus x1 is 4 minus 3 squared, and then plus y2 minus y1, 3 minus 0 squared. Now I can tell you that one is going to be the square root of 10. Can I tell you what the square root of 10 is in the calculator? Should be 3.4ish. 3.16, no, you're right. 3.16, okay. Now, we know that FG is 3.6, and we know that PQ is 3.16. Now we're going to figure out which is the shortest way to do this, okay? So let's have a look. Would it be possible to... Which is the shorter path from A to B? So A to B, guys, yeah? So you can go two ways. You can go 3 plus 3.6 plus 4. What does that get us? 10.6 if you go from A to F. F to G, and G to B. Does that make sense? And the other way is going to be what, guys? A to P, 3. P to Q, 3.16. Q to R, 2. And R to B, 3. Any idea what that is if we add them all together? It's going to be 11.16. Which root is shorter? Root A to F, F to G. A to F, F to G, G to B is the shorter one, and this one is A to P, P to Q, Q to R, R to B. It's a bit longer. Would it be possible to reduce the distance on either path? I'd argue no. If you're only allowed to go A to F, if you're only allowed to go along this, what does it say? The shopping centre. You could arguably do something like this. Like if you only have to get around the blocks, don't you? What happens if you did something like this? Then straight across. That'll be 5 blocks plus. That one might be quicker, would it? Or yeah. What Cameron's saying there is that you could move R closer and then just go up like that. That'd be a bit quicker, wouldn't it? So there is ways of doing it shorter. Make sure you cut a diagonal across the pitch rather than going up and across. Makes things a lot faster. Okay, guys.